Good morning, sixth graders. This is one of our last videos for the year. It's kind of a bittersweet time as we think about the end of the school year and just not really being able to say goodbye face to face. I thought we'd talk today about the interior angles of a triangle. Now, if you watched the Math Antics video yesterday, this won't be completely new to you. If you didn't watch it yesterday, I really encourage you to go back to Google Classroom, find that link, and watch it today at some point. There's some things that they can just do so much better than I can do with their technology. But if we look at the word triangle for a minute, the prefix tri, of course, means three. And then the next word is angle. So a triangle has three angles, three corners. We're going to talk about the measurements of those three triangles, or three angles of that triangle, and figure out some things that we could possibly do with them. I have for you 5 examples of triangles. Each has a measurement in the corner. The measurement measures the angle of this vertex. You should be able to see that the first triangle is what we would call an equilateral triangle. Every one of those angles is the same measurement. Every one of the sides the same length. The next triangle is a right triangle. It has a right angle in one corner. It's also an isosceles triangle because 2 of the sides are the same length. This kind of left side and this bottom side are the same length. The third side would be a different length, probably longer than the other 2. We have another isosceles triangle, but this one, instead of being a right isosceles, is an acute isosceles. All the angles are acute, but 2 of the sides are still the same length. Down in the bottom left corner, we have what we call a right, because it has a right angle. Scalene triangle, because the sides are different lengths. All 3 sides measure different lengths. So this is a right scalene triangle. And finally, we end with an obtuse scalene triangle. It has an obtuse angle in it, and all 3 sides are different lengths. So we have an obtuse scalene triangle. You may be wondering, why do we show me all these things? But there's something fairly interesting. And I don't know who figured this out. Some really smart math person a long time ago figured this out, that if you measure all the angles within a triangle, it always adds up to be the same amount. If you watched the video yesterday, it would have told you that that sum is always 180 degrees. So 60, 60, 60, that's 180 degrees. If you don't believe me, feel free to use a calculator and test these. 45, 90, 45, again, 180 degrees. 70, 70, 40, that's 180 degrees. 60, 90, 30, add those up, that's 180 degrees. And so would this last one. 35 and 15, that's 50 degrees, plus 130, they add up to 180 degrees. Knowing this allows us to do some things in geometry that are pretty helpful. Here's an example of a triangle where we know 2 of the measurements, but one of them is missing. We're going to call that angle B. So we know this angle is 100 degrees. We know this angle is 60 degrees. But there's an angle missing. So if we use what we know that angle, the 100-degree angle, the 60-degree angle, plus angle B has to equal 180. It's not an option. That's the only thing it can be. So I'm using some of my algebra skills. First thing I did is I combined my like terms here. I added the 100 and the 60. I got 160. So 160 degrees plus angle B has to equal 180. Now, I know some of you probably already know that answer, but I kind of used my algebra skill of balancing my equation. I subtracted 160 from the left side. I subtracted 160 from the right side. And I was left with B equals 20. So what I know now is that angle B is 20 degrees. If I were to go back and add the 3 numbers together, 60, 100 plus 20, I should get 180 degrees. It's kind of a neat little thing that we can do. Now this one's a little trickier because 2 of the angles are missing. We know this angle on the top is 120 degrees. We know that these 2 are missing. So I look around for clues and I see these little blue tick marks. These blue tick marks should tell us that this left side and this right side are in fact the same length. That gives me what we call an isosceles triangle. In fact, it's an obtuse isosceles triangle. There's a really important detail here that because these two sides are equivalent, or in geometry terms, we would say they're congruent, they're the same length. We know that these two angles, angle A and angle B, must also be congruent. And that's an important detail for this question. We know that the measurement of angle A and the measurement of angle B will be the same measurement. So let's use some algebra skills right now. We know that angle A plus angle B plus 120 degrees must equal 180. It's kind of a proven fact in geometry that it always equals 180 degrees. If I subtract 100 degrees from the left side and 100 degrees from the right side of the equation, that tells me that angle B and angle A together must equal 60 degrees. So 120 plus 60 would be 180 degrees. But that doesn't mean angle A is 60 degrees, because if angle A was 60, angle B would have to be 0. We would not have a triangle. It would be kind of funny looking. So we don't know exactly what that would be. So that tells us that these two together have to equal 60. So if I take 60 degrees divided by 2, we're just going to split those degrees evenly amongst angle A and angle B. We get 30. So now A is 30, B is 30, and if we were to check this, 30 plus 30 plus 120 has to equal 180 degrees. 180 degrees is the sum of every triangle in the whole world. That is an important concept, and that's what your little bit of homework is about today. Today, I'd like you to go to page 462. I'd like you to just do 4 of these, just enough to kind of get the hang of it. Okay, so we have questions 5, 6, 17, and 18 on page 462. Remember, the sum of the interior angles of any triangle must be 180 degrees. The sum of these angles must be 180 degrees. So if you did the assignment yesterday, where you did the 4 questions from yesterday, go ahead and put this on the same Google Doc. And then we're going to have one more of these small assignments on Thursday. And when you've completed all 3 of them, go ahead and share that Google Doc with me. A few of you shared with me yesterday's homework, and I'll probably be getting around to checking those later on today. But I don't really need it until you have all 3 of them done. Thanks for listening. Have a wonderful day.